All right, so let's talk z-scores. All right, so the formula for z-scores is the data value minus the mean over the standard deviation. Okay, I've given you the formula for the sample and the population. It does not change. The only thing that changes there is, remember that the population standard deviation is different. So let's talk about what z-scores mean. A z-score is a statistic that indicates how many standard deviations a particular data value is away from the mean. If the z-score is positive, the data value is above the mean, and if the z-score is negative, then the data value is below the mean. So if you have a Bell distribution, all right, if it's negative, it's over here. If it's positive, it's over here. All right, so z-scores can provide us with information about the data set without knowing everything about the data set. It helps us identify outliers, okay? We've talked a little bit about outliers in the last lesson. We're going to talk about outliers a little more in depth this lesson. So outliers are extremely large or extremely small data values that lie outside the quote-unquote normal range. So if you have the heights of humans, here's an average person. Say, I don't remember what the mean of male adult heights is. Say that's 6 feet. An outlier would be a dude that's 8 feet. Okay, because there's 8 feet is very uncommon. It's extremely large. Another outlier would be a little person that is 2 feet tall. Adult, of course. Okay, so 2 feet and 8 feet are outliers in heights of adult males, or at least in my little world of data that I kind of just made up. All right, so let's talk about some guidelines here. A data value is considered not unusual when the z-score lies between -2 and 2. So that would be -2 is less than the z-score is less than 2. Okay. A data value is considered moderately unusual, so like 6'8". A male of height, say 6'8", that would be between -3 and less than or equal to -2, as well as 2, but less than 3. Okay, if it's equal to 2, it lies within this section. A data value is an outlier if the z-score is greater than -3 or greater than less than -3 or greater than +3. So z is less than or equal to -3, or z is greater than or equal to +3. Okay? Now let's talk about the empirical rule a little more. Now this doesn't always hold true. They have to be normal. Now make sure that you know the difference between normal and symmetric. Symmetric is not necessarily normal. Okay? It does not equal normal. This doesn't hold true all the time. So it's only when it's normal, when it's laid out perfectly like this, that this really holds true. So let's continue and talk about the empirical rule in terms of z-scores. About 68% of the data values will have z-scores between -1 and 1. About 95% of the data values will have z-scores between -2 and 2. And about 99.7% of the data values will have z-scores between -3 and 3. Okay? So that's a way of thinking about the 68, 95, 99.7 rule in terms of z-scores. Now let's break it down a little further. As you can see, this picture is broken down in halves. Here's the 68%. So 34% of the data scores will lie between -1 and 0, as well as 0 and -1. 13.5% of the z-scores will be between -2 and -1, and so on. So let's do an example. We're going to talk about calories in the 12 breakfast cereals. So our calories are here, and we're going to write our z-scores here. First thing we're going to do is we want to find the z-scores for Corn Flakes, Basic 4, Bran Flakes, and Captain Crunch. But we need to find the means, and that's going to be done in Excel. I have the data loaded up in Excel already. For finding an average, okay, I'm going to go to Auto Sum, Average. You can also find it in the More Functions feature. And we don't want these blanks to come into effect. So notice this says B2 to B15. Our data values actually stop at B13. So I'm going to go ahead and edit that to be B13. I could drag, but this is editable. I'm going to press enter, and that gives me a mean of 109.2. The next thing we need to do is we need to find the standard deviations, or standard deviation. Excuse the typo. So I'm going to do that in Excel. I'm going to click the box I want it to happen in. Now this is a sample, so we're going to use standard deviation sample. Click on More Functions, Statistical. Whoa, I messed up. Statistical. Standard deviation sample. I'm going to collect my data values. I can go ahead and select them. If you can't select them, like for some reason if you're on a Mac, you can just type in your data values. Just make sure your colon's there, because that represents from this section to this section. Okay, so our standard deviation is 11.65. All right, so we got the mean, 109.2. Find the mean and the standard deviation. The standard deviation is 11.65. Now we're going to calculate the z-scores. I could do this by hand, quote unquote, by writing the formula out. So I'll do that for this one. 110 minus the mean, which is 109.2, over my standard deviation, which is 11.65. But that's a lot of calculations. I'm going to show you how to make Excel work for you. We're going to escape out of this. Yes, I'm going to keep those. Let's go to Excel and make this work for us. I'm going to show you a little trick on how to program Excel. I want to calculate these z-scores for the Apple Jacks, the Basic 4, the Bran Chex, the Bran Flakes, the Captain Crunch, the Cheerios, Cinnamon Toast Crunch, the Cocoa Puffs, the Corn Chex, the Corn Flakes, the Corn Pops, and the Count Chocula. Let's make Excel work for us. I want to find the z-score. Now, remember that the z-score is the data value minus the mean, over the standard deviation. Okay, so when I want to program a formula into Excel, I press equals. Okay, and that's going to tell Excel that I'm programming a formula. So I'm going to put some parentheses in, because we have to be very, very careful with order of operations. And when I want my data value, I'm just going to go ahead and click on the data value I want, subtract it by the mean, which I've already calculated in Excel, close the parentheses, and divide by the standard deviation. Enter. My z-score is 0.07 for Apple Jacks. Now, I can do this without typing it repeatedly, so I'm going to drag and drop. Now, notice you have division by 0 here, because if you look at these formulas up here, this is B16. We need to fix this, okay? We need to make this so this doesn't change in the formula. So I'm going to type in a $sign in front of the B and a $sign after the B. That tells Excel that I only want B16, which is right here, to be that value. I don't want that to change, okay? And, oops. Okay, and notice that this formula appears wrong. I need up here that B15 to stay fixed as well. So $sign. Now I'm going to drag and drop again. There are my z-scores for all of my data sets. So I'm actually just going to copy and paste that into our PowerPoint display because I can. I'm going to delete that. Goodbye. And just like that, they're there. Let's make it all cute. What size font is this? 18. So now we have the z-scores for all of our data. And hopefully that gives you a good insight on how to work with z-scores. You're going to have more problems out of Chapter 3. And this z-score is going to translate into more stuff that we're going to do later on the road. Everything builds on top of each other. So you need to always make sure you know how to use the mean. You know how to calculate a standard deviation. And now make sure you know how to calculate a z-score, either by hand or in Microsoft Excel. Happy working.